Okay, here is an arbitrary K-map. It's actually exactly like the one from the previous video. So the values from the truth table have been put in this Karnaugh map. So Karnaugh map or K-map is used to minimize the sum of product expression. From a truth table we get a sum of product expression, which is the combination of AND gates and OR gates. So several AND gates and connected together by the OR gates. So that expression can be minimized using Boolean algebra, and K-map is an alternative to Boolean algebra. To minimize the expression, K-map can be used. So basically all these squares in a K-map is actually consists of adjacent variables. So from one square to another square, the variable that's changing is just one. So here it is a bar, b bar. So this square means a bar, b bar, c bar, d bar, while this second one means a bar, b, c bar, d bar. So the only one variable changes from one square to another adjacent square. Similarly downwards, it's just, if we go down, it's a bar, b bar, c bar, d. So from here it's only b that is changing, and from here to here, from this one to this one, it's only from this one to this one it's b changing, and from here, this was like a b bar, so from here to here it's only, should be d bar, yes, from here to here it's only d that's changing, from this one to this one it's d that's changing. So yeah, but from here to here these two are not adjacent, the diagonal squares are not adjacent, because if we see, the change is more, because here it is a bar, b bar, c bar, d bar, so more than one variable changes, and this one here is a bar, b, then c bar, d. So that's the changes. So b also changing, d also changing, so that's not adjacent anymore. So what is done in a K-map is, we want to take care of the ones and we want to make a group of ones. The group will be either 2, 4 or 8. So basically they are power of 2, 1, 2 or 4. So 2 to the power 0 means just by itself, either group of 2 or group of 4 or group of 8. So I will just rewrite the original values there. So there was nothing, sorry, so it was an empty, so yeah, that's the one. So this is my original thing. Now to start grouping, we should notice two things. First of all, we want to make the as less number of group as possible. We have to take all the ones into groups, but we have to make as less number of groups as possible while taking all the ones, and we also will try to make the group as big as possible. So if we look at the first one, we can see that with this one it could go with this one here, this is an option, or it could have gone like that, it could have gone like that. This is another option, this is another group as well. There is no other option with this one, there is another option which is this one and this one. So all these things are adjacent, so whatever is whichever is convenient we can take. So if we start like that, we can see this is one group. We need to write the expression. While writing the expression, we have to see that the expression is a bar, b bar is there, while for this one and this one the only thing that is common is d bar, because c bar is changing, so that's d bar. That's the expression for this group. Now looking at the second one, for this one I have to, the only option I can take, only option I have is this one, because this one I can take a group like that, but that way if I take this one, then I will have, instead of this one, if I make this group, then actually I have also been able to take this one. this one as well. So that's better, because I don't want to make too many groups. I want to make as less number of groups as possible. So okay, this one if I take, the group will be C bar D is common here, and looking at the top, if I look here, the common is only A bar. So A bar, that's my expression here. Going. Now I have to take these two, this one. So what I will do is I will take these two here, and I will take this one here. So I will write this one later. First let's write the first one, this one. Here common is C bar D bar, and this one is B is changing, so A is the only common thing. So I could have written A in the beginning, but that's okay. This one I will take this one, so this one is already also taken care of. So this will become here AB is the common, because that's the common only here, and going this way the only thing that's not changing is D. So I have to take the common that is not changing. C is changing, it's C bar here, it's C here, so I have to write what is not changing. That's it. Now only this one is left. I can take it by itself, but that will yield a bigger expression. So I want to make the group as big as possible. I can take one as many times as needed, that's not a problem. So I will make this one this group. That's the only option actually I have, because it doesn't go with anything else. So here again, this is common, C bar D, C D bar, sorry. And for this one, this way, the only thing that's not changing is A bar, because B is changing. So that is the minimized expression that I am getting from here. Also the group size can be any power of 2, so it could be 16 as well. So if there were all ones, we could form a whole big group with all the ones there inside. So yeah, like that, everything there. So yeah, and also as we saw that we could have formed other groups like that. Like the group could have been, I will use a different color, it could be this one, and then something like this one would be there anyway, and then this one had to be there, this one had to be there, and this one had to be there. So basically we would still get 1 2 3 4 5 groups, but the expressions would be different. So we could have ended up with different expression, that's fine, but basically by minimization names is how many number of AND gates and OR gates we are needing, that would be the same whichever way we group them. We can get different expressions, but the number of AND terms and number of OR terms will be the same if it is minimized properly.